Okay guys, so we're gonna try something a little different. I was having a little bit of problems recording the meeting with Zoom, so I'm gonna try just recording something separately and seeing how it works. And if you guys do like this setup different, or better, I mean, actually email me and let me know because I have been thinking about just recording videos and uploading them and seeing if that works a little bit better than working with Zoom. So for the most part, I think a lot of you guys have already taken a look at the practice exam, and if you do have questions on that, you're more than welcome to email me. But I just kind of wanted to go over a couple little general pieces that I thought would be kind of useful to just keep in mind when you're talking about the exam. So first off, let's kind of just make a couple different charts to refer to. So we have our, let's not do x, f prime of x, f of x, and that should be good. Okay, so when we are talking about f prime of x being positive, or that could be a plus sign, or we could be looking at greater than 0, all of those are kind of the same idea. Remember that when the derivative is positive, the function itself is going to be increasing. Okay, and then the opposite is true when the derivative is negative. We're going to be decreasing. And I made this table way bigger than necessary, so we're just going to shorten that up really quick. That's kind of just a brief recap. And remember that when we're talking about finding intervals of where the function is increasing and decreasing, our first step always is to find our critical points. So to find critical points, I'm gonna write that in pink because we can. Not my cleanest, but we're gonna roll with it. Okay, so to find critical points occur where the derivative, and typically we see the derivative referred to as f prime of x, is either 0 or undefined. So to find our critical points, we want to look for where the derivative is 0 or undefined. So to do so, we need to find our derivative first, and then we can set it equal to 0. Or a lot of times when you're talking about undefined, you're going to be looking at a function that has like a numerator and denominator, and you can set the denominator equal to 0 to find where the function is undefined. Once we have our critical points, we can make ourselves a sign chart. And remember, a sign chart kind of looks like, say this is our critical point. We're going to either be 0 or not defined here, and then positive or negative over here, and positive or negative over here. And this is for the derivative. This is for x. But we can also make these sign charts for the second derivative, and that will tell us concave up or down, but we'll get into that in a second. The other thing to note about sign charts is whenever you're given an interval, it's a really good idea to include that interval on your sign chart. It just makes it a lot easier when you're actually trying to give your answer if it's already kind of written out for you. So say that our interval is from A to B, and say we're just going to say that we are increasing here and we're decreasing here. Doesn't really matter what's going on at the critical point at the moment, but then that's going to give us that f of x is increasing on, we're going to say A to C, and since A is an open parenthesis, we're going to use an open parenthesis when we're writing it. But instead, if it was a bracket, you would use a bracket there. So you just kind of coordinate the interval with what you're given. And then we're going to say that f of x is decreasing on C to B. But you always use an open parenthesis around your critical point. That never gets a bracket or a closed parenthesis. Okay, square bracket, whatever you want to call it. Okay, so that's really all we need to really cover with first derivatives. Just positive or negative relates to increasing or decreasing. Okay, and now when we're talking about second derivatives, we can write out f prime of x, f of x, and this time I have a better idea of what I want to say, so I shouldn't need as much room, hopefully. So we have greater than 0 and less than 0. So remember that when you are greater than 0, you are positive, you are smiling, you are concave up. Not you specifically, but the function is concave up. And when you are negative, you're frowning, so we have concave down. And rather than trying to keep that straight in my head, I just always draw the little pictures. I really think it helps, but that's just how my brain works. Okay, so that's kind of our chart for our second derivative, and maybe let's move that guy over here, give it a title just to make it a little bit more organized. So if you guys want to try to make sense of these notes down the road, you have something to actually look at. Okay. And then when we are talking about making a sign chart for the second derivative, it's really the same idea as before. Just replace increasing, decreasing with concave up or down, and then you would just put like a little dash there. And that's really it. Okay, so that is our second derivative. The other part that goes along with the second derivative is the second derivative test. Okay, so we can make another little chart for that. So we have f double prime of x, f of x, and interpretation. We're just going to write it as interp. Okay. And we are looking at C is a critical point. That means that f of c equals 0 or f of c, f prime of c, that's my bad, does not exist. That's what we mean by critical point. Okay, so either second derivative is positive, it is negative, or it's 0. 3 possibilities here. Okay, so when this is honestly just the same as what's up here, so we can just say concave up, concave down. And this doesn't really tell us much about what's going on with f of x. It could be an inflection point, could not be an inflection point. And then our interpretation, when we are concave up, you can look back at this little picture. We're going to have a local minimum there. Okay, and then same with concave down, that's going to be a local maximum. And then when it's equal to 0, that's just going to be inconclusive. We can't really gather anything from when the second derivative is equal to 0. It's kind of, in a sense, meaningless to us when we're talking about the second derivative test. It's not actually meaningless, but we can't gather much from it. One thing that I forgot to mention in regards to the second derivative is inflection points. So inflection points are like critical points in that we find them by looking at the derivative in question. So in this case, the second derivative, either where it's equal to 0 or where it's not defined. Okay, the catch with inflection points is it must change sign. So say that we have, let's put P here for point. Say we're looking at our sign chart. This is 0 or not defined. We have to go either from positive to negative or from negative to positive. Okay, on our sign chart, we have to change sign for it to be an inflection point. Oops, not sing. And we don't need that to be that big. Okay, and maybe I'll just pull a little box around her. Really keep it straight. Okay, awesome, awesome. And it's still a little too close there. I like that. Move it right there. Cool, cool. Okay. So that's basically the majority of what we need to know for second derivative. Not much goes beyond that. And honestly, this is the gist of what you guys have covered this chapter, is looking at first derivative. Let's get this a title here too, keeping everything straight. Really just covered first derivative, finding critical points, and then second derivative test. That's really the bulk of what was covered this chapter. And then, you know, going back and forth from either having a graph and finding its sign chart or information about its derivatives, or vice versa. And that's really just referring back to these charts here, okay? So if the function is increasing or decreasing, then you know what's going on with the first derivative. And if it's concave up or down, then you know what's going on with the second derivative. So it's just kind of working either direction with those charts that you're given. And then the only other real element to this chapter was looking at kind of absolute versus local. And we kind of already touched on this. But so with absolute extrema, they can only occur either on a closed interval or if you only have one critical point in an open interval. If you don't have either of those two cases, then it's local. We'll say otherwise local. Okay. And then going along with the absolute versus local, that's kind of where 11.6 comes in, looking at optimization of functions. Really, there's not much more involved with optimization. One thing that I will tell you is kind of caveat, extra little element of it, is that a lot of times with real world problems, you want to be finding closed intervals if you can. It's not a hard and fast rule. Just when you're talking about in the context of a real world, we have a lot more constraints on what we put on things than we do in a more theoretical sense. So for example, when we're talking about price, even though when we're looking at math, you know, price might just be a variable, when we're talking about price in the real world, that cannot be negative. We cannot have a negative price for an item. So that introduces constraints and intervals that we will impose on a function. So that's just kind of something to keep in the back of your mind, that if you can, it's a good idea to see if you can find a interval for the problem. It's not always a hard and fast rule, like I said, but just something to keep in mind. I think that is about it for kind of just a quick rundown of the course. Well, this chapter, not the whole course, obviously, but just of this chapter. So I think that should be everything. I mean, not everything, but I think that's everything I want to cover. There's definitely a lot more that you guys can look at. I would definitely recommend you guys looking at 11.6 because there's a lot of really good word problems, and if you do have any questions, you're more than welcome to email me about those problems. Otherwise, this is kind of the bulk of the information that you need for the exam. There's a few little things here and there that are extra little catches. I gave you a couple of them at the end of last week's discussion. But yeah, just some things to keep in mind, and hope everyone is doing well, and I hope you good luck on your exam. And lastly, if you would be willing to just email me, let me know what you think about this different setup for discussion, if you like it better, if you prefer if we just did this versus the Zoom meetings, then I'm more than willing to work with that. So just let me know. Thank you, and have a good rest of your day.